Hello. So Steve asked me to kind of update you on the Van Gogh rack and kind of what has been happening in the last months since I last presented this to you. And so yeah, I can just I think the best idea is to just kind of go through the thesis draft and explain kind of what we've been doing. So the argument for the whole thing is basically just saying that we shouldn't really be using LLMs for character embodiment kind of as they are, like as zero shot generators, but instead to kind of create some cognitive strategies to improve the potential of LLMs for character embodiment in HCI. And the way that we did that was kind of by making an offline episodic memory dataset. Um, so I can go through the dataset first here. The first thing that we did was we created, well, we're calling it actually an autonoetic dataset, because, well, autonoesis is like positioning yourself kind of in your memories as, in this kind of first person view, this ability to, when we try to remember things, we kind of just place ourselves in a memory. Um, so yeah, we grab Van Gogh's full biography. So I basically have here a bunch of chunks of Van Gogh's biography. Each one of like the UID series, so 22 here will be the chapter 22, and then we split it in chunks. So this will be like some paragraphs. It's around 3 paragraphs per chunk of Van Gogh's biography. And we also grab all of Van Gogh's letters. So down here we have all of his letters. And we used all these to rewrite, or rather, we asked an LLM to rewrite all of these. So if you see here, we basically told an LLM, okay, you are a screenwriter and you need to rewrite these pieces of the biography into a script. And so the script contains usually background information about like kind of the actual scene, then a narrator that kind of explains overall what's happening in the scene, and then the autonoetic memory of Van Gogh, right? So the whole point is to make Van Gogh explain the book kind of as himself, which is kind of just an autobiography, sort of. But the idea is to make it more of a memory biography. So it's not him writing like in a diary, but rather kind of him remembering things. So yeah, it's interesting. For example, this second one, this second chunk, I like it because it talks about when Van Gogh killed himself, or rather when he tried, like when he shot himself and then didn't fully succeed, and so he needed to return to the inn where he was staying. And so, yeah, like the LLM kind of rewrote this in a very poetic way, kind of explaining that, there was like a gunshot, and then after that he went back to the inn, right? So it's the same content, but this is kind of rewritten in a Van Gogh poetic way. And so with these three pieces of information, like with the background narrator and the Van Gogh autonoetic kind of memory, we then used another LLM to extract a bunch of numeric and other kinds of informations from these memories. So we asked an LLM like, okay, you're a Van Gogh expert, and so for example, extract like give us the context of this scene. Tell us like your expert opinion on the scene. Kind of like what do you think about it? Do you think it's important, not important, etc. And then extract the characters. So which characters were involved in that specific scene, and like valence arousal. So give a score for. Actually, what we originally did was we asked the system to be like, okay, tell us if it was a happy or a sad memory. And then, sorry, there was like a strange noise. So just tell us like, give us emotions. So it would write like a list of emotions, and then we grabbed all of those emotions and we translated them into balance and arousal, like averages. So the idea here was to extract a bunch of numeric data that we can then use, and I'll show you how we used it in a second. And then some timestamps. So basically, like tell us like what year this happened and around what day and what month. And then we also asked the expert to tell us like, and this expert is an LLM expert, so it's an AI, to also tell us like where does this scene take place, like in which area. And then we use another API to basically transform those places, locations into latitude and longitudes, and then just to rate like if the memory was important or not. And so I'll go a little bit more into how we're using this dataset, but the first thing that we did with the dataset was to do some visualizations. So we can go through there. somewhere here. So yeah, we can, for example, I mean, this graph is probably my favorite. We can see like we can graph all of the balance and arousal of Van Gogh's life throughout his life. So we can see, first of all, like valence, which is kind of sadness versus happiness. We can go here. It's mostly negative, which means like Van Gogh's life mostly was negative, which we kind of already know that, like he had a very dramatic life. So yeah, we can see here like all of the negative values. And something interesting, for example, here is that the arousal kind of remains static, and then around these times, then it starts to go up. But then when arousal goes down and valence goes down at the same time, so we have some pretty big valence dips here, but the arousal keeps going up. But then when eventually the arousal goes down and the valence goes down, then that's the end of his life. So I mean, just some interesting insights about the graphs. We kind of checked, how many times each character was mentioned in his kind of autonoetic memories or episodic memories rather. For example, we also extracted like the mentions of his love interests, and they do happen to, all of these peaks do happen to happen exactly when we know for a fact that Van Gogh was like or had these romantic interests. We also created this system. So wait, I think it disconnected. So let me quickly pause and check something. Okay, yeah. So this we created this interactive graph here, so I can change stuff, and then when I run it, let me just remove the paths for now. So this is basically representing the data set that we have, but it's representing it. We use like a PCA analysis to represent it graphically. So it's kind of, we can think of it as like literally like Van Gogh's cognitive memory dataset, or Van Gogh's like cognitive memory system. So all of the numbers are here. Right now, for example, it's color coded as a balance and arousal, which basically means these yellow points here are the happier memories, and then the dark ones are the sadder memories. So we can see like a nice smooth transition between them. And so, of course, when we hover over this, we can see like the UIDs, so 50, 18, etc. So we can actually go to that chapter and that chunk and extract that memory, which of course is something that I want to do more properly, so when you click on it, you can actually see the memory to the right or something. But right now, at least we can access them by hovering over them. And so, yeah, for example, I do like to put balance and relevance only here. I think it's my favorite graph. So we can see the memories sorted by relevance. So the least relevant ones and the more important ones, more and more and more. And then, for example, there's only one memory rated as the most relevant memory of them all. But then the cool thing is that we can actually extract the conversations that we have with Van Gogh. So basically, once we go into the chatbot and we talk with the chatbot, we can actually extract that information, and then we can see the conversation as it happened in the dataset. So for example, here, if you see, we have here center one. So this would be the first. So basically, when you make a question and you get an answer, that would create a ping point. So every time that you ask something to the chatbot and you get an answer, then ping points are created. So this would be the first question answer pair. This would be the second one, third one, fourth one. And so we can kind of trace the path of the conversation, like we can kind of see how it went around. And moreover, we can also see the memory. So for example, we can see that this first question and answer, when we ask something to Van Gogh, then Van Gogh referenced this UID 3.1, so with this memory, and I know this one 11.2, etc. So this second question here access some other memories and so on. So it's cool because it gives us a bunch of explainability tools here. Like, whenever we're talking with Van Gogh and we see Van Gogh's answer, that's one thing. But then we can actually go and kind of understand which memories were extracted from Van Gogh's answers, and kind of just interpret them. And this whole thing was, I mean, the path conversation thing was Steve's idea. So it's a really brilliant kind of path thing that we can do here. So yeah, that's kind of the data set and some of the visualizations we can do with the data set. And then after that, what we did was basically the actual chatbot. So I can just show you here kind of how the chatbot works. So right now there's two main racks and everything. So yeah, the whole point of making the data set is that we can make an offline data set. So that means that when I ask things, so for example, I'm going to ask like, who is Theo? Then it really takes in this case, 0.5 seconds to make a whole very large and very well thought of prompt, which is way faster than most systems out there right now, because most systems, what they ask the system to do is to kind of self-reflect on these things. But because we already kind of did the whole autonoetic self-reflection in the beforehand, like offline, then we can just extract that and then use it for their answers. So yeah, what's happening here is whenever I ask the question, so right now I asked who is Theo, what happens is that we go into the data set, we go into the, this one, yeah. So we go into the data set and then we look for, so this is the augmented passages that we're using right now for the embeddings. So basically we're putting dates, characters, and then the whole memory, so the part of the biography, and we're embedding all of this. So basically we're grabbing and saying, okay, all of this goes into the embedding of the RAG. And then when we ask a question, so we look for the passages that match that embedding. And then we don't really use this passage, which is kind of the extra thing that we're doing. But instead, we kind of just extract all of this information here. And then with all of that information, we just make our super extensive prompts. And this is the old dataset, by the way, like the chatbot that I just activated, because these dates have been corrected right now, because this 1700, nobody was alive, like Mango or Theo. So I already changed this, but I'm using the old dataset still because there's some extra things that I need to change in the new one. But yeah, so yeah, we extract the three memories here, the three most relevant memories from the question. So if you see, these are the autonoetic version of the memories, so the first person version of the memories. And then we put like a static prompt. So basically it's like you're Van Gogh and you should kind of like answer this way, do this. And finally we add another paragraph which contains all the numeric information. So your emotions are neutral, positive in arousal, etc. So all of the stuff related to all of these numbers that we extracted here. And so all of that is just access to the to the kind of long-term memory part of the system. Of course, we also have the short-term memory because when I ask questions, we just put that in the chat, like we just put it back in the chat. But eventually, the attention does run out. So we also have another rack system, which is taking the same information, so the same autonoetic data set, it's putting all that into another rack, like a separate second rack. And then we're grabbing the question and answer pairs and we're putting them also in the rack. So what that allows us to do is, for example, I'm going to ask something completely different right now. Let's just say like, what happened to your ear? And so it's going to give us, the answer about the ear. If you see, it's accessing again the autonoetic dataset. So three memories here related to his ear. And then if I ask him again, like, okay, like tell me more about Theo, then if you see, not only is it going to, hopefully, not only is it going to access the two autonoetic memories from Theo, but now it's also going to access some chat memories from the past. So it's cool because we could be talking with the bot for 1 hour, long after the attention span left the questions about Theo. But then because we're also storing these ones in a rack, then whenever we ask another thing about Theo, then we can extract the memory again. We can tell, okay, so this happened some minutes ago, and we put here the question pair. And so what's cool is that many times, I don't know if it's going to do it right now, so it decided not to do it, I think. But usually when you ask, like, it's going to kind of reference the fact that it already answered you. I think it didn't do it right now. Let's just ask it again, like, tell me more about your brother. So if it does access the memory up here, so yeah, it accesses these memories from the conversation plus the autonoetic memory. And then, funnily enough, he's not doing it right now, which is fine. But normally what he does is kind of he makes a reference to the previous conversation because we're putting it there, right? So I don't know, let's ask more things about the ear. Why did you cut your ear? And then there you go. So like now because we already mentioned this before, then it does say like, okay, we already talked about this, right? So yeah, I mean that's just some interesting things. So it has like long-term memory, it has short-term memory with the normal chat chain, and it also has like this intermediate term memory, which for the most part it really always references it. It's funny that right now that those two questions he didn't really reminded us that we had talked about it because it almost always mentions it this way. But right now it did, so it's basically saying like, okay, we have touched upon this. And then, yeah, I mean, some extra stuff that I added, like now it tries to make conversation. So it not only does it say things, but now also he also asks questions back. So you can actually talk to him. And because he has the intermediate and long-term memory and short-term memory, they can actually kind of keep the conversation thread. And then just to finally finalize this, because I think I'm taking more time than what Steve asked me to take. But we tested this. We use like this framework for kind of using another LLM to judge the quality of the responses. So we're not using humans here. So basically, we ask an LLM like, okay, here are two responses, and then basically rate which one is the best response. And so we tested like the system only kind of like the whole thing. So the autonoetic memory plus the static prompt plus this extra information like the numeric information. So we tested the whole system against only the static prompt. So basically the answer, asking the question and just giving him this piece of the prompt. And in that case, we fully won, like the full system won like 23 times. The LLM judge preferred the full system instead of the only static one. Then we did one without this question. So basically, we added the autonoetic dataset and the static questions. The static like part of the prompt, but we did not add the arousals and the Van Gogh, like the character section. And the system, the judge did prefer our full system still, which means like it's useful to have this extra paragraph here of numeric information. And then the most interesting part probably is like when we paired it against a simple RAG. So basically we created a RAG in which we just put the whole letters and biography, just dumped it in there, no autonoetic like kind of rewriting of the memory. So just all of the information and then just extract it randomly, like whenever we ask questions, not randomly, but like rackly. And then we actually tie it up. So our system versus just like kind of a traditional RAG in GPT-4, the judge kind of paired them up. So we had like a lot of tied questions, and then it prefers 6 questions and then 6 questions from the traditional RAG, which basically what that means is that our system performs just as well as a traditional RAG. The cool thing about this is that even though it performs just as well, we still do have like all of the explainability of by looking at the graphs and the interactive graph and all that stuff. But then what's more interesting is that when we went into like less high performant networks like GPT 3.5 or DaVinci, which is GPT-3, our system did win again, and it win by 15 and 10 and then 15 and 12, which basically means as the system starts to become less and less performant, it seems our system does become better and better, right? Which is good because, I mean, at least me personally, I'm very much, I know that Steve is working with Vanessa on climate change and AI and all that stuff, but yeah, like I think it's not ideal to keep thinking that we can keep expanding, models like GPT-4, like making GPT-5 larger and larger. So rather we do want to start kind of trying to go back into smaller systems. So that's kind of what we're trying to imitate here by going into GPT 3.5 or DaVinci, which have the same kind of performance as many small systems that you can put into your computer. Then this kind of much more structured way of showing the information and asking queries to the to the LLM helps a lot, right? So GPT-4 is quite good at kind of just understanding context from random things, and that's why if you just put a traditional RAG with just like a bunch of third-person context of the biography, it still understands things. But whenever we go into like smaller models, like less performant models, then our system again performs better. So yeah, that's pretty much the whole thing. I think I took a lot of time now. So yeah, that's pretty much it.